Imagine waking on a cold winter morning to the aroma of fresh coffee. The sun rises, and as the south wall collects heat from the increasing sunlight, a large insulation panel slides away from the bedroom window. The concrete floor is warm. The air is still and quiet. Your favorite morning music begins to play lightly as you eat your breakfast. And as you drive away, your house automatically locks. Thermostats reduce. Insulation panels close. Music shuts off, and the house hibernates until you return from work. Virginia Tech's LUMENHAUS is not just a house imagined for the future. It is a working prototype that utilizes computer technology, architectural design, and energy efficiency in an integrated way that enriches daily life.
We've chosen a very provocative position. We've decided to make a solar house that's a pavilion. At the same time, our concept of responsive architecture will allow the house to adapt to the different conditions.
The idea of responsive architecture is, can a house be 100% energy efficient with the use of the computer, with the use of technology, while at the same time not sacrifice comfort and quality of living for that user?
The house can easily open to the outside with natural cross ventilation. Through a system of low-energy, motor-driven and computer-activated panels, the pavilion stay can be effortlessly converted to a well-insulated and well-shaded, energy-efficient space.
One aspect of sustainability in our house is that it is very energy efficient. We have the ability to open and close a lot of our openings. They're operable to allow for user comforts and to adapt to a changing environment.
Insulating walls made of polycarbonate panels and aerogel move across the two glass facades. A system of shade panels designed like shutters lets sunlight in during different seasons but adds privacy to different spaces.
The outer layer is a sunshade, which opens and closes using servo motors. The second panel is an insulation panel that allows us to have this open pavilion when the weather is good, because obviously when the weather is good, we want to take advantage of good weather, and that's the most energy efficient you can be, is to stop using your systems when you don't need them.
A complex building control system utilizing an easy-to-use iPhone application allows control of the house from wherever you are.
One of the great things about the iPhone is there will be one application that's titled Energy Use. It'll have a little meter with the dial rotating. If you click on that meter, it will show you every device in your house that's using energy. And it actually will give you control to toggle on and off those devices. Giving the public a device that shows them where they're using energy, we see as a real positive. We think that that will affect how one uses energy.
Simply click on your house icon and choose one of the many house control options for temperature, shading, insulation, and even your lighting and appliances to optimize and balance energy efficiency with personalized living requirements.
The concept of this house is responsive architecture, and that is in one part because of its response to the environment. We have a weather station on this house that's connected to a computer, which is connected to sensors, and the weather station tells the computer the weather conditions outside the house.
This house is designed to respond to two significant demands. One is the demands from external conditions that deal with weather and different climate. So the computer will sense what systems it needs to deploy to optimize the energy use and also maximize the comfort for the users. At the same time, there is a strategy by which the individual can control the house and overrule the computer.
The house converts energy from the sun to generate electricity through solar panels on the roof that adjust during the seasons.
A regular solar panel has an opaque background, so the sun does not travel through it. The Sanyo Double Hit has a glass background, so what sun doesn't get absorbed going through the first time will reflect back and hit the back side of the wafer, causing another change in charge and more current to flow and create more power.
There are two heat pumps in the house, a water-to-water heat pump and a water-to-air heat pump. They're both fed by a geothermal system, which gives us added temperature control and added temperature energy boost for the systems.
A geothermal system uses the earth as a heat sink, basically. In a typical situation, you would have pipes that are sent into the ground, either vertically or horizontally laid in the ground. And it uses the temperature of the earth to keep those pipes at a median temperature.
The water-to-water heat pump heats the radiant floor and the domestic water. The radiant floor is the best kind of heat you can have because the air temperature can be kept lower than normal ambient temperature. There's no moving air, so the atmosphere seems much more comfortable. And also it's completely quiet, so there's no sound in the air system.
Through responsive architecture, our house is able to do many tasks. Operate insulation panels, operate sun shading screens, operate photovoltaic panels on the roof, operate the music that plays within the house, the lighting that's in the house, and curtains that are in the house. All of this can be controlled by the user.
Architecture of small space is a critical aspect to designing this house.
The interior is bookended by two cores, which are all wood. And in the center, there's a bathroom core, which is wood as well.
We have a bed in the bedroom that can fold up like a Murphy bed to allow a different use for that bedroom at different times. The home office is made up of two nesting tables. These tables can be relocated in a different area of the house for different functions when the office is not being used. The kitchen has a sliding cabinet that conceals the kitchen when the kitchen is not being used, but allows additional workspace when the kitchen is utilized.
It can also be pushed out towards the edge of the house and used as a bar to serve outdoor food, because the whole dining room setup, the table, its chairs, can all be moved outside for outside dining, and it'll serve as a serving platform for those meals.
We have closets in the bedroom that open to close off the bedroom if you want your private space. And when the closet doors open, there's a flat screen television behind it. So if you're in your bedroom watching television and you have guests in the living room, you can close that off and still be able to maintain a private space.
You know, it's a very tough task to transport an entire house and rebuild it in a matter of 3 or 4 days.
An innovative transportation system allows the house to be transported easily with very little on-site construction or assembly.
The entire house is built as a transportable unit. There's no need for a flatbed.
You then have removable components on the front and the back. The bogie, which is the wheel assembly on the back, and the gooseneck, which is also a removable component on the front, that will allow us to transport the house and to immediately or easily release these two elements, leaving the house as a house and not as a trailer or a mobile home with wheels left behind.
We've taken a very provocative stance. This house is a pavilion. Therefore, it's completely open, and for the 6 months of the year where the house can be open, it expands out to the outer reaches of the decks, therefore making a seamless boundary between inside and outside. Thus, the house is a lot bigger than its small 800-foot footprint. In that regard, I think it will offer a better quality of life because it'll be more energy sustaining, it'll be more economical, but it'll offer a complete richness of daily activity that any house does on the market today.
Working closely with the architecture, mechanical engineering, and electrical engineering students and faculty, Virginia Tech has used the concept of responsive architecture to create a house that can operate at an optimal energy efficiency 24 hours a day without compromising the comfort and beauty of a modern architectural home. The Virginia Tech Lumen House, bringing the future to life.